Hello from Manchester in the UK. I'm Abby Stone and I'm giving this presentation on behalf of myself and Heather, who sent her apologies she couldn't join me on the recording. And what I'm going to be presenting then is what we found out some time ago now about the terrific tufa that we find in the Naukluft Mountains. And this opening picture is a bit of a teaser. You can only see tufa in the foreground. I'm standing on top of one of the very large cascade features of Tufa that stand around 100 metres above the valley. And in that valley, the Tsondab River is flowing from east to west out to the Namib Sand Sea. So I'll show you plenty more pictures of what this Tufa looks like from different angles in the presentation. I'm going to stop the video so the file size doesn't become too large. Okay. So what's the take-home message? I suppose it's simply to impress upon you that the tufa in this region are numerous and impressive, and I'm sure many of you have seen them. And the aims specifically are to show you plenty of photos to help you explore the morphologies of these fluvial tufa with me, so that I can then characterise a conceptual model for these, and you can see how far you agree. And then outline the successes and challenges when it came to uranium-thorium dating of these features. So, photographs of these terminal cascade features. Here is Brandfontein, here is Bleskrantz. This photo taken back in July 2005 in the winter months. And thank you very much to Christy for sending me this photograph from February 2009, when it's a lot wetter and there is a waterfall thundering down from that position where he took that opening photograph. There's the Arboid adult system, slightly different shape and size. And if you then flip to the southern draining system, to the Waterkloof Trail system that flows into the Naukluft River, you can see these similar magnitude systems, similar size, they're perhaps somewhere between a cascade and a barrage. On that north-facing side then, all of these cascades line up along this break of slope. And I think I remember email conversations during my PhD with Christy, where you told me about this being somewhere where there's a steeply northward dipping fault, which is coincident with that range front. We can look across and see where we're going to find those cascades. As you walk up into these valleys, then you find other regions where there's breaks of slope, where you get smaller cascades of a few meters high. Lots of barrages of tufa that span the width of the fluvial channel, associated with quite a lot of bedload, as you can see. And perhaps this is a hybrid somewhere between a cascade and a barrage in the Waterkloof. There is a lot of fluvial bedload, I don't think unexpected in these semi-arid systems. You see it uncemented at the surface at the top. You see it cemented in tufa, a matrix-supported tufa, fascies, which has been eroded, sometimes right down flat. And these units are covered by non-classed rich tufa units, phytoherm units around vegetation. There's a lot of evidence for fluvial incision, scour pools at the banks, through very large barrages themselves, even some biogeomorphic erosion by trees. And sometimes it seems that the system's working at the slope with also some fluvial incisions, and this is at the Arboid adult. So if we start to put that whole catchment together then, we see the terminal cascades, the frozen waterfalls at the range front. We find barrages up through the system. We find lots of areas with gravels being deposited, many of them uncemented, some of them cemented. And at the front of these cascades, large boulders are falling off the front. Okay, so with those photos in mind, I hope I can now talk you through the conceptual model that Heather put together with colleagues that was published back in 2007. Because the organisation of the morphology and fascies type, the barrages, the pools, the cascades, led Heather and colleagues to propose there's a relatively simple system going on, but there are three contrasting flow conditions under which this happens. Now, in the first phase, there's perennial low energy flow and barrages start to form at natural breaks of slope or over boulders like this. And the barrage system forms, there's rapid enough flow to encourage moss growth, there's degassing of carbon dioxide and precipitation of this tufa. And water is ponding up behind these barrages, creating slackwater environments where other features are forming and reeds are growing. But then there are, in phase 2, some episodic high flow that starts to erode these and deposit these, this bed load, patchy erosion of the tufa, sometimes complete obliteration, as you'd see down here in F. Okay, you might also get a lot of colluvial processes happening on the hill slopes, providing a lot of material to enter the fluvial system. Now, the third phase then is a bit like we see today. There are ephemeral water flows which help to reduce or eliminate in-stream vegetation and lead to the deposition of some discontinuous tufa drapes. Okay, I'll show you a photo in a moment. Okay, so I hope that that makes sense to you. What we can also do then is contrast this with the semi-arid and the temperate models of fluvial barrage formation that's been proposed by Pedley and others. And the key things to point out then are the shape of the barrages. So over here, in the Naukluft, we've got downstream pro-grading systems where the fronts are dipping downwards, okay, as you see here in C and D and E. Okay, and also there's a lot of tufa cemented gravels in those pool regions at the fluvial channel, at the sides of the channel, matrix supported tufa cemented bedload. Now, as we walked around this during my PhD field research, we could see this repeated across all 4 catchments. And as a quaternary scientist, that's quite exciting because it starts to look like maybe there is a regional response to changing hydroclimatic conditions in this region. So with that in mind, I set to work collecting samples in the field for some geochronology, so for some uranium thorium dating. And these are the kind of things I had my eye out for. Nice, dense, cemented units without too much porosity that look quite clean as carbonates as tufa carbonates can. So those are my focus for dating, just to show you then that it's things that have formed. I said I would show you one of these flowstone drapes, things that formed as flowstone drapes or as kind of vuggy fill, almost like flowstones inside these little miniature cave areas. All this lovely banded stuff in the quiet water in pools that were filled with water behind barrages. I took some other test samples, why not? While you have an opportunity to do that, it's something that's interesting to do. And just to remind us then, when we are uranium thorium dating, we are assuming that our carbonate has no thorium in it at the time of deposition. And we're also hoping that our carbonate has remained a chemically closed system. That's a kind of red flag for all of this stuff that's quite spongy, that water's going to flow through and maybe take uranium out of or add more uranium to. So I did lots of subsampling. If subsamples repeat, that gives you a good idea that your date might be believable. But in doing this thin section work to help me work out where to put my microdrill and sample my carbonate, the thin sections to also help me characterise the types of cement I was seeing, whether they are spar, microspar or micrite, and to characterise both porosity and any presence of detritus from clay through to silt through to gravel sides. And I did a little bit of this, photoluminescence, which can indicate alteration of carbonate fabrics. Let's start with the good news then. I got something that looked really sensible from this vug fill in the Waterkloof National Park that had formed in the barrage. Okay, for those of you that are uranium thorium minded, there's some key data on there. You can perhaps pause and have a look at that. But the repeatability across this sample is pretty good. So what are the implications for this? Well, I'm going to borrow Heather's model and develop it for this large barrage system in the Waterkloof. Before incision, happily forming, then you start to get some erosion, you get some of this bed load in there, re-cemented, repeats through time, then you start to get some erosion of this barrage system, incised all the way through. During one of these phases, maybe there's ponded water, maybe there's flowing water, this banded facies was forming in the hole, and it's centred on around 80,000 years ago. In terms of what that means for Quaternary, that's the end of marine oxygen isotope stage 5 in the global system, showing that there is enough water flowing in this system for that to form at the end of stage 5. And that some of this incision's perhaps going on then or just after. Okay, so finally it gets incised all the way through. Now this is another sample where I had some success, one of these flowstone drapes. And you can see that part of it is just over 4,000 years old and the other part is just under 1,000 years old. So way up here in the Holocene, showing some drape tufa, some flowstone forming in the system. Unfortunately, that's where the success ended. So I'll just tell you a little about the dating challenges. This one here, we've got in the black box, this parameter of the thorium ratio is telling us there's detrital contamination. We can see it in this thin section. We can see some silt and sand and almost gravel-sized detritus, and we can't get an age at all for this one. And then 200 and something and 11,000 years for these two. It just doesn't seem to make sense. Okay, so all of the samples in my data set that had detrital contamination, we attempted to correct for this. And you use these things, they're known as isochrons or mixing lines, and if they should be a really good fit along those lines, if the subsamples have got detrital contamination, but it's all the same source, but there's different concentrations of it in what I microdrilled. Now, if they fail, we've got 3 possibilities. Maybe there was more than one source of detrital contamination. In that case, we can't correct for it. Maybe there's been loss of uranium. My system was open. And maybe there's multiple phases of cement and cement alteration. Okay, so there's a picture showing some of the detritus. Perhaps I've got multiple sources of detritus with different thorium signatures. Here's the cathodoluminescence photo, microphotograph, to show you that there's been, in the reds, some alteration of the fabric. Now, in another group of samples, this was my challenge. It appears to have experienced open system behaviour. Okay, so in this, I like to call it a banana plot, and this sort of diagram by Villemont and Fallou. This is an open system model where you can take into account loss and gain of uranium-234, uranium-238, and thorium. Now, hint, the point shouldn't fall outside the banana plot, okay, and things shouldn't really have this ratio greater than 1. So this is all quite puzzling. Now, again, there's probably 3 reasons why samples aren't behaving well. And in this version of my banana plot, first of all, we've got to constrain some free parameters. If we believe that WMP sample is around 80,000, we can bracket around the 80,000 line there. Things that are this side show that there was gain in uranium. Things that are this side of the solid line show that there was loss of uranium. Okay, so 3 possibilities. Maybe the samples are really old. They're greater than 350 or 400,000 years. Are they controlled by loss of uranium? Yes, well, maybe these have lost lots and lots of uranium. And we also explored in the paper rare cases there might be mobile thorium, hydrogenous or unsupported thorium. Okay, so it got pretty complicated, but that's the highlight. So in conclusion, the Naukluft Mountains, I hope I've convinced you, contain numerous and impressive tufa deposits. The arid and semi-arid model of tufa formation involves 3 states of our fluvial system. Uranium series dating, mixed success. Some believable stage 5 into stage 4 and some believable Holocene ages. Perhaps much of this is just way older than we can constrain. And some samples, lots of detrital sources, perhaps other evidence for open system behaviour. And I'd say overall, there is a lot left to learn about these terrific tufa.